Good morning, all.
Good morning.
Morning. I'd like to welcome you all to today's webinar organized by the Watson Project. My name is Eleni Hadjidimitriou, Project Manager at Reframe Food and Pilot Coordinator of the Watson Project. Watson is a European Horizon project of 47 partners across 20 countries, aiming to tackle food fraud, ensure food authenticity, and enhance food traceability using its comprehensive digital framework. In today's webinar, we will be exploring together the following questions. How can we reduce food fraud? Working in three different food supply chains, specifically olive oil, meat, and honey. Each of them will present the process and examples of how the Watson technologies and innovations are being used to expose and prevent fraud. Today's webinar is organized in different talks focusing on these three food supply chains. First one, the traceability of extra virgin olive oil, the genetic and digital tools for a safe and value chain presented by Nicolo. Secondly, how to catch adulterations in the meat chain presented by Manuela Peckert. And last but not least, when technology meets tradition, safeguarding the authenticity of PGI honey of Asturias, presented by Armando. Our presentations will be followed by a session on with questions and answers, where we'll have time to discuss with our pilot experts. And I really want to say that this is truly a unique opportunity to learn about the tools and strategies being applied in different agri-food sectors, and to also understand the specific challenges and solutions that are associated with the proposed solutions. Now, whether you are working on in food production, regulation, or research, this webinar really offers valuable insights and an opportunity to engage with a growing community focused on food integrity and innovation. Now, before we move to our speakers and presentations, I would like to say a few words about housekeeping. The webinar is being recorded and it will be posted on the Watson Project website after our event. Please turn off your camera and mute your microphone. Use the chat and for your questions and comments, and we will address them at the end of the presentations. And finally, if you need captions, there is an option. Please click on more and then language on your more options, and then you will find an option to turn on automated captions. Our speakers today, Nicolo Cultera, pilot leader of the extra virgin olive oil pilot, senior researcher from CNR in Italy. Manuela Peckert, pilot leader of presenting the meat pilot, a research scientist from MRI, the Max Rubin Institute in Germany. And last but not least, Armando Menendez Estrada, project manager and leader in Nancycar and leader of the Honey Pilot. I would like now to kick off the webinar with our first speaker, Nicolo. Nicolo, the virtual floor is yours. You can switch on your camera and open your mic.
And microphone. Okay, thank
Thank
you.
you.
Thank you very much. Good morning. Thank you for the invitation, for the opportunity to present activity which concern the use of genetic and digital tools to ensure safe, high quality and traceable Evo production chain in shared governance and privacy principles room. To this, you can switch. Okay, thank you. To do this, I would like to thank all the partners and the direct collaborator who are making this work possible. Next slide, please. We need to protect Evo because it's a prized Mediterranean product vulnerable to fraud due the climate impacts, high demand, and the fragmented supply chain. Common issues include adulteration, mislabeling, and false origin claims. Despite strict regulation, current testing methods are costly, slow, and hazardous, highlighting the need for robust traceability, so we can sue as a track and trace system. Please, the next. The approach along olive oil safe chain aims to ensure the authenticity of and the traceability of extra virgin olive oil in 4K control points, combining rapid and low-cost DNR fingerprint technologies integrated with blockchain-based technologies and digital ones. For example, the early warning system, the digital food product, and the QR code in the bottom. For each stage, specific data was collected from the technological solution that we propose, and specific timestamp are integrated, paving the way for real-time monitoring and traceability application, while also providing tools for subsequent checks, validation, and anomaly detection. For example, data at the orchard involve the creation of a solid reference database of harvest up to mill, and the involved user are the farmers, the owners of the mill or olive oil, the producer who buy the olives. The data at the mill verifies the origin and integrity of the olive oil from field to storage, and the user involved are the millers and the olive oil producer. At the producer, trading company or retailer, recorded data connects the stored olive oil and its bottling, offering traceability back to the field. The last step, the last target are the consumers, the final reference point for the Watson technologies to get what they paid for. Please, the next slide, Lenny. Okay, Watson introduced portable tools for rapid DNA extraction and artificial intelligence and machine learning genotyping for on-site Evo authentication, safeguarding for product integrity throughout the production chain. We want to focus on the possibility of obtaining safe results in only in a few hours compared to a few days that are for the normal traditional laboratory without wasting material and reducing cost. The DNA-based technologies offer key advantage and benefits for extra virgin olive oil authentication, including the authenticity and traceability of varietal composition, fraud or adulteration detection, precision, geographic origin, governance, and privacy respect. The benefit are the fraud protection, product differentiation, company profit, consumer trust, society comfort, and planet benefit. Please, the next slide, Eleni. Based on standard ontologies, Watson was designed to model the information collected during the scenarios considered, including field and fruit processing to obtain the finished product and storage, transportation, and packaging. The food supply chain interoperability layer semantically describes and persists or fix the data, enabling smooth collaboration between pilot data source, including IoT infrastructure and human operated measuring device. Data for stakeholder, authority control body, and consumer managed by the digital food passport and early warning system and an app mobile. The next slide, please. With a single scan of QR code on the bottle, the FPP, the digital passport users access immutable blockchain verified records that track the product journey from source to shelf. This data ensure the data integrity, strengthen supply chain accountability, and provide secure real-time information to the stakeholder at every stage. The next slide, please. The early warning system, by its side, use artificial intelligence tool to detect any anomalies and declared olive production data, such as trees and the quantity of olive oils, the genetics, the number of packaged bottles, powered by reference historical models and climate data. This help safety authorities in risk of assessment and fraud prevention. The next slide, please. Interesting label transparency and information for the consumer on the origin integrity and authenticity of Evo can support them in making more informed choices. The preliminary consumer satisfaction data from Italy, Greece, and Switzerland reveal that the most respondents value greater traceability on product label, ideally accessible via QR code. Interestingly, the price appears to have a little influence, with consumer prioritizing product quality and country of origin. The last slide, please. Thank you. The Watson traceability holistic approach is revolutionary for Evo, for extra virgin olive oil traceability, by combining traditional metadata tracking, origin, lot numbers, logistic, with DNA-based certification on the oil's genetic identity and digital blockchain-based technologies that are integrated, as I said before, on a digital passport for a digital food passport product and the rewarding system, respectively for the stakeholders and the authority control and the consumers. This multi-layer system guarantee both product integrity and information reliability. Okay, thank you very much for the attention. Okay.
Thank you, Nicolo. Thank you for your very interesting presentation. I do find it like very challenging and interesting that you are trying to gather data and apply the solution throughout the value chain. I would like now to move to our next speaker, Manuela. Manuela for the meat value chain.
Good. Do you see me? Yes.
Yes, thank you.
Yes, thank you very much. And I also would like to thank you for the opportunity to present our work from the meat case. Yeah, the general question was how to catch adulterations in the meat chain. And yes, upon closer examination, this question is really broad because the meat sector is a highly complex sector and much less standardized compared to other food industry sectors, like, for example, honey. In principle, yes, everything you see here, a very, very simplified scheme of the meat chain. In principle, everything starts with a primary production on the left side here. No, we start with at the farm. After finishing of the animals are usually transported to a slaughterhouse, and from there the further process depends on the species. For example, in the case of pigs or cattle, they are typically cutted and deboned, and the resulting meat goes either directly to packaging and marketing, or it is further processed to, for example, sausages or convenience products. In contrast, chicken meat is often sold as whole birds or portioned into cuts like breast or legs. Then the manipulations, if you can imagine, might occur at every stage, and it might, for example, involve either the animal species. It can involve the production system, for example, under which welfare conditions the animals have been raised. It can happen that the slaughter practices are not that they are labeled. You can have substitutions, especially at this in the processing plant, substitution of highly valuable parts of the animal with cheaper ingredients. For example, the injection of water or using cheaper meat parts like organs and so on. So for the meat case, we chose 4 representative scenarios. And the goal was to develop new approaches to better detect adulterations and to ensure, or that will ensure, further meat authenticity. So the first use case here, it deals with the false declaration of grain-fed animals as grass-fed. Then the second use case focuses on fresh chicken meat, where the injecting of hydrolysate solutions into the meat can lead to an increase in the weight of the sample, of the product. And in the use cases 3 and 4, we are working on minced beef products, which can either be substituted with organ or with meat from foreign species. So for the differentiation of the grass-fed and grain-fed animals, a handheld near device has been developed and tested. So, and the stakeholders in that case would be the control authorities, but also, for example, larger butcheries to ensure a proper declaration of the grass-fed animals. And in the other use cases, analytical methods have been developed, mainly intended for the use by food control authorities. So yes, now let me introduce you the 4 methods. So in the first use case, you have the problem that Consumers show a higher demand for meat produced under higher welfare conditions, such as a preference for grass-fed animals instead of grain-fed animals. However, if you can imagine, it is nearly impossible to control the feeding of the animals on a daily basis. And therefore, our colleagues from INRAE developed a method to distinguish the feeding regimes, and they implemented a handheld near device or a near-end with spectroscopy device, which you can see on the right side here, which can be directly being used in a slaughterhouse or a cutting plant. And huge advantage of the new method is that it is extremely quick. So the acquisition of the spectra is very fast, it is non-invasive, and so that a high throughput can be ensured. And the main work lied, of course, in the development of the statistical models for an accurate differentiation. Right now, the method has been successfully implemented, and statistical models have been trained on fat and on muscles, and now shortly before, the models has been tested under different conditions. And for example, Donato was visiting us in Germany to test the animals in our slaughterhouses. There has been a comparison between laboratory measurements and measurements at the butcher shop or slaughterhouse, and also a spectra from different time points have been compared and checked for the proper evaluation of the spectra. And right now, Donato and his colleagues are finalizing the evaluation, and yeah, I might say that it looks very promising to implement this method as a very fast screening method to differentiate the grass and grain-fed animals. Then in the second use case, the detection of foreign protein hydrolysate in chicken breast meat by MALDI-MS imaging. So the problem here is that the weight of the poultry breast fillet can easily be increased by injecting water. However, if you only use water, it is very easy to detect this by controlling the water-nitrogen ratios in the meat, where certain threshold limits exist. So what you can do is you just take very cheap hydrolysates, which result from byproducts or residual materials of the food industry. And then you inject these liquid hydrolysates into the chicken breast meat, and you can easily get a gain weight around 10 to 15%. So right now, no standardized method exists, so that is legally defensible to detect those fortifications. And our colleagues from the University of Bayreuth, they have developed a new method to analyze the distribution of amino acids in the meat with a so-called MALDI imaging mass spectrometer. So you just take a small cut of your meat piece, then you prepare a small slice out of it, put it on a slide, then a so-called matrix is sprayed, and the sample can then go directly into the measurement. And what you see here in the pictures on the bit below is that the distribution, that you can visualize the distribution of molecules. And here, for example, shown the distribution of hydroxyproline or glycine, which are typical components of collagen hydrolysates. So the advantage of this method is that it's highly sensitive and very selective. Now you can directly measure the distinct amino acids compared to microscopy. And it is less laborious compared, for example, to analytical methods like HPLC, where you have to do extraction processes and then chromatographic runs to run the methods. Right now, so the methods have been developed, amino acid markers have been identified, and Andreas and his colleagues are now working or further characterizing the samples for different time points. What happens between the injection and the analysis, if there are certain time points in between, like storage days, and how can they characterize different types of hydrolysates, not just collagen, for example, but also whey protein or soy proteins. In the third use case, we have the detection of beef organs in minced beef products by LC-MS. So here, which was also a very famous case many years ago, the substitution of beef muscle meat with cheaper substituents. And one of these substituents could be, for example, organs from the cattle itself. And the problem would be here that would be, of course, not detectable by PCR methods. So what our colleagues are developing is how to identify those adulterations. And therefore, they developed analytical methods using liquid chromatography coupled to mass spectrometry to identify specific peptide markers for the various organs. And the advantage here is that this method can simultaneously detect the various organs within one run. So you don't need any previous knowledge what kind of organ would have been introduced. This could be detected with one method. And heat-stable markers allow the analysis of cooked products, which is a huge advantage, especially for sausages. And after final evaluation, this method can have a potential high sensitivity and accuracy to finally go also for further validation process at the DIN and ISO method. Right now, the method development has been finished, and now our colleagues are working on unknown samples provided from project partners to further evaluate the method. And the least use case detecting also adulterations in minced beef, but now the substitution of foreign species. And here we have the same problem that more expensive beef meat can be substituted with cheaper meat from foreign species. Here, for the Watson project, we chose for the substitution with pork meat, and compared to all other use cases, we have here an standardized method already existing based on qPCR. However, this qPCR method is targeted, so you just need to know against which species to test, and it is more laborious. So we are going to develop new methods that are either quicker, easier to implement, and are not depending on previous knowledge which kind of foreign species would have been introduced. We use two methods. One method is using peptide fingerprints, so it's also mass spectrometry based to identify markers of foreign species. And the second method is DNA based, DNA metabarcoding to quantify DNA markers. The advantages are quite different. So the MALDI method is a very fast and a very cheap screening method. It might not be practically as a legal defensible method, but it might be a tool for first fast screening and cheap screening. In comparison to that, the DNA metabarcoding is able to simultaneously identify various species in a one meat sample. It is quantitative, and it is also has a possibility to get or to become a standardized method. Right now, also the method developments have been finished. For the fingerprinting method, we are extending the training data sets. So because similar to the NIR method, the major work lies always on training and testing statistical models. So we are further working on that. And we also have materials provided from our project partners to independently demonstrate how the methods are working and applicable for unknown samples. So with that, I would like to thank you all our colleagues and partners involved in this project and that make this project possible. So thank you very much for your attention, and I'm happy to answer your questions in the end.
Thank you very much, Manuela. I can see your excellent efforts in increasing the capacity of food authorities in detecting meat adulteration. Let's wait for the last session on discussion to discuss further. I would like now to invite Armando back to the spotlight. Thank you, Armando. I'm giving you the floor.
Thank you, Lenny. Thank you very much, and thank you. The main problems of this value chain. So we are focusing in the honey production in Asturias, in a small region in the north of Spain. So we are working with the products certified by the PGI entity. So all of you probably know that honey is a nutritional healthy profile. And in Asturias, this product has a long-standing cultural and economic significance. So this is very relevant and very important for our region. Also in Spain, it's also very important. And yes, we collaborate in this pilot with the Asturian PGI honey. So this entity represents the symbol of the authenticity and quality of this product in the region, and guarantee the quality and the traceability to the consumers. So this is the context, the product we are focusing this pilot. In the problem, I would say, the problem with this product is obviously due to this nutritional and healthy profile. The honey is a perfect substitute or alternative to common sweeteners than sugars, syrups, all these kind of sweeteners. But obviously honey is much more healthy, but it's more expensive than these other products. So this is the core of the fraudulent activities in this context, in this value chain. According to the Joint Research Center and in collaboration with the European Anti-Fraud Office, there is a report that say that 46% of the honey products in Europe analyzed was a study. They studied more than 300 honey samples from 20 different countries. So 46% were suspicious to be adulterated. So if we focus this context in Spain, 51% of the honey of the honey products arriving in Spain are adulterated. So this is a very big problem at national level, at European level, national level. Also, could be a problem here in our region, in Asturias. And yes, this more expensive value of this product is the main reason, because the main fraudulent activity is the adulteration of the products by mixing with cheaper sugars, mainly Chinese syrups. There are two types of syrups that are the main substitutes of honey, syrups from rice and corn. Here. In addition to this problem, to the adulteration problem, this is one general problem. There is in Asturias we have a specific problem related with the mislabeling due to botanical origin. So in the slide you can see a graph with three different sections in the graph. From the lower part is the honey, the Asturias honey products labeled as multifloral. Okay, so this is the lower part of the pyramid, so the price is lower. In the middle part, there are the honey products that can be labeled as with specific botanical origins, so can be labeled as mountain, coast, or forest, and the final price is a little bit higher. And then in the top of the pyramid, there is the monofloral products that are the most expensive one. And yes, these products are based on specific botanical varieties. The rules of the PGI are very complex, so depending of different parameters, physicochemical parameters, pollen analysis, organoleptic characteristics, depending on all these type of parameters, the producer can label the product as multifloral, as mountain, coast, or forest, or monofloral. So sometimes there is mislabeling in different products, not only for fraud purposes, but only for it's a mistake of the producers. So this is a problem. So this is the context in terms of the problems and the mitigation. How can we mitigate these problems, adulteration, mislabeling? So obviously to increase the quality controls. But the current technologies used for honey quality assessment are very time consuming. So the food control authorities need several days for getting information about the samples. The analyses are destructive and expensive, are very expensive, and the results needs the interpretation of the expert knowledge because are complicated, the techniques are complicated, and well, this is complex, and there is an imperative need to develop fast, non-destructive, easy to use, and low-cost analytical methods to detect adulteration and mislabeling in honey. So this is the main objective of the pilot, and the technologies involved we have developed in this pilot. The first one is the AI-assisted near-infrared sensor device. We focus the two use cases explained before: the detection of added sugars or syrups in honey, and the detection of mislabeling due to the botanical origin. The final end users of this sensor will be the Food Authority Control, so the PGI, and as well as the regional government that is also in charge of these quality controls. And the current status of the development, well, regarding the near sensor device, so we have selected the specific configuration. So we have selected the most suitable commercial hardware for this purpose according to the needs of the end users. We have adapted this hardware for the specific applications. So we have developed a special holder for managing these samples. So the honey is a very complicated sample. It's liquid, but with a very high viscosity, so it's complicated. And we also develop a software interface for providing the results to the end users. The preliminary algorithm was already tested during the first validation campaign, and now we are validating the final algorithm during the final validation campaign. And this sensor will help to better identify and prevent fraudulent practices, because we'll provide real-time response information to the end users. The end users can make in situ quality controls, and they can analyze 100% of the batches. So these are the main benefits. The second technology here is very similar to the previous one, but in this case, with the same use cases, but in this case, we are working with hyperspectral imaging technology. The target end users are the same, because it's again addressed to the food control authorities. And the current status of the development, so we have defined and optimized all the parameters involved in this technology, because for this technology, the illumination is critical, and other parameters that must be optimized before the validation. And yes, we validate, or we test different configurations in order to see which one is the most suitable, is the best one for this application. And yes, we are validating the algorithm in this second validation campaign right now. So well, this is in progress, and the benefits for the end users will be the same. So the end users will get real-time information. hyperspectral provides more information than near, but it's less portable. So it's not handheld as the near sensor device. So the portability is lower, but the accuracy is better than the near sensor device. And again, the end users will have the possibility to analyze 100% of the batches. This is the software that we have developed for the project. So it's very easy to use. Just the users click on the start button, put the sample on the sensor, and they get the results about if the honey, the product is adulterated or is pure honey. Okay, this is an example. The same for the botanical origin. And there is another technology involved in Watson project, integrated in Watson platform. This is the early warning system. The target end users is the same, so the food control authorities. And this is the system created for providing early warnings to the end users about the possibility that one specific samples can be adulterated or can be a mislabeling due to different parameters. So the early warning system is composed by different layers: the processing layers, that prepares and configures the data set. The predictive layer is the main component of this tool, because here there are the predictive algorithms analyzing all the data. Then there is the explainability layer that collects input and output from each of these modules to produce the explanation for each outcome. And finally, the outputs from the main modules of the predictive layer and the explainability layer are gathered and presented in the visualization layer. So how this will help to the end users for the food quality controls. So the system is fed by different type of data sources from the value chains. Even the near and hyperspectral outcomes will fit this system, weather conditions, all this kind of data. So the information that the end users can get from this tool is very useful for them. And yes, finally, the early warnings generate fraud probabilities. And in case that these probabilities are higher than a specific number, a specific threshold, there is an alert. And yes, this information is provided to the end users. And the last one is the mobile app. So in this case, the Watson project has developed a mobile app to inform the consumers about nutritional traceability values of the honey products. Obviously, the target end users are the consumers in this case, and this is in progress right now. And this application will provide information throughout the honey value chain, providing information about where is the apiaries, where is the production site, the packaging site, even providing information about the chemical analysis. So all this information will be provided to the consumers. Yes, in order to make it to ensure the transparency and traceability of the product. And well, this is all from my side. So yes, any questions or comments, it will be great to answer you. Okay, thank you very much.
Thank you very much, Armando, for an excellent presentation. There are already some questions for you. We have 15 minutes left, so I would like to allow time now for the questions and answers session. I'd like to invite back our speakers to the spotlight. So please, Manuel and Nicolo, switch on your cameras. Thank you very much. And I would like now to start with Armando, since he was the last and it's still very fresh. We have a question that was submitted during the registration process, and it's a general question that is also very relevant to the Watson framework. How does AI, how is AI used for the detection of honey adulteration in your case?
in the case of honey, we are if we are referring to the sensor devices, optical sensor devices, near infrared and hyperspectral imaging technologies. Yes, we collect. We are our methodology is we work getting data, generating the data set with different samples and generating the spectra of each sample. And then with this data is correlated with all the information provided by the PGI and also by our laboratory that we analyze the samples. We made some physicochemical analysis and pollen analysis, and then we apply different machine learning techniques for creating the algorithms based on artificial intelligence techniques. So this is the same for this is for adulteration, but also for mislabeling. We follow the same methodology for both technologies. This is the way we are working right now with the artificial intelligence.
Thanks a lot, Armando. I'll come back to you later on. I would like now to ask Nicolo a question that came in. Nicolo, how does the Watson solution integrate with the needs of the European community in terms of implementing traceability throughout the food supply chain?
Thank you for this question, but what's on holistic solution for the traceability of olive oil supply chain respond concretely to the global agenda for sustainable development from the United Nations in 2015, and its goal to be achieved before 2013. And to answer also to the declaration of the development of blockchain technologies in the context of the distributed ledger technologies as emerging technologies and those based chosen from European economic for the economic development of Europe. The main objective would be the centralization, the user-centric approach, yes?
No, it's
the greater transparency and more effective controls. I think a little bit of noise. Okay. For sure, the fundamental principles are ensuring standard interoperability and convergence of national regulation, strengthening research collaboration involving public and private stakeholders, ensuring the confidentiality and the protection of personal data, and promoting fair competition to foster the development of a new business model with particular attention to the startups and the small medium enterprises.
And Nicolo, last question for you. Why does the genetic solution you've chosen, how there is potential for broader adoption of this solution, and what's the long-term impact of it?
Well, the DNA-based solution is effective both in achieving its target on olive oil traceability and its implementation in the digital traceability system to ensure the olive oil supply chain is high technologically and feasible. The results are objective and answer a specific question only if the number of the markers is sufficient to highlight the genetic diversity, of the oil trading system, but they can be automatically integrated into an artificial intelligence and machine learning based analysis system. The analysis results can be recorded directly within the interoperability layer developed that can be connected to the blockchain directly. Furthermore, the technology that we designed can be portable, and the analysis time can be shorter than before, requiring only a few hours of working staff work. It's quite inexpensive and relatively environmentally friendly.
Thank you very much, Nicolo.
Please.
Manuela, there was a lot of interest in the methods you are developing within the meat pilot, and there was a question on details. Can you provide more details on the upcoming steps of the validation process of the methods, of the analytical, specifically the analytical methods?
So yes, so in that case, usually if you have successfully developed a method in the lab, then usually you publish it, there it goes through a review process, but then that it becomes a really standardized method under how it's called in Germany, it's paragraph 64 method that can then also be implemented into a DIN and ISO method. You have to go through a very thorough validation process. So at first of all, you, for example, need to produce a lot of reference materials. Then the reference materials are distributed to many, many different independent laboratories to test the method. So you have to provide a full explanation of the process that different laboratories can then follow the instructions and test the method. And then the results are compared to confirm reproducibility, to confirm robustness of the method, accuracy, and so on. And only if this is successful, then the method goes into a review process from the standardization committee, and it's then adopted as an official method. And also then it goes periodically under a review and for further update. So we can't hear you. Are muted, Eleni?
Yes. Thank you very much, Manuela.
Okay.
So can you tell us in a sentence, why is it so hard for the meat sector to ensure authenticity, especially compared to the other products, olive oil and honey?
Yeah, so if you can imagine, so meat is not just one matrix. So you have a fat part, you have a muscle part, you have different contents of water, you have connective tissue parts. So this is from the biological point of view. It's very complex composition of the different cuts. You have various genotypes. We have not just the animal species, but various genotypes. And then we have so many products. Everything that goes into a processing step for sausages, for convenient products, there's an incredible amount of recipes which can be end up. You have the different production lines from biological, ecological production to a very let's say less welfare implemented production systems. And then you have various marketing strategies. You can have one really huge industry which owns everything, which owns their slaughterhouses, cutting plants, and processing plants for final products. And on the other end of this, you have the tiny, tiny small producers who directly go to a farm, slaughter their single animals, use a single animal to make final products, and you have mixed up everything. And this makes it hard among this huge amount of products, marketing strategies, to have just a few methods. You would need so many to meet all possible manipulations, you would need so many techniques, methods, and so on. So you can just concentrate on what's the most relevant one.
Thank you, Manuela. It's indeed very challenging. Armando, I'd like to come back to you with a question regarding the acceptance, the understanding of these tools from the stakeholders. I know that you had a very successful workshop already organized, inviting diverse stakeholders. So can you let us know the level of acceptance and understanding of these technologies you are developing?
Yeah, it's a good question. For us, was a challenge because obviously in this value chain, in this sector, the producers, packers are not very familiarized with digital technologies. So all these kind of platforms, softwares, sensor devices is difficult for us to show them how is the performance or how is the fundamentals of this technology. But during the first workshop, yes, we made during the first validation round, we provide a training session for the end users. This was the first step. So the end users must know how to use the sensor devices, not to understand what is behind the algorithms, okay, because this is not the purpose, but how to use the sensor. So that's the reason, because we focus on this type of sensors must be very easy to use, handheld devices, easy to use, easy to understand. Yes, we with the end users, we get a very good feedback about the work with the sensor devices, and then in the workshop we present these digital tools to other stakeholders, producers, packers, and again we had to explain in a very easy way to understand what is this technology, and the most important is to show them the benefits that they can get from these tools, not only for the end users but only for the producers, because and packers, because they are also packaging honey for other producers. So probably in the future the packers can be end users of these sensor devices. So yes, and the feedback was very positive, because the workshop was focused on that, only explaining the performance and the benefits. So finally the feedback was very nice, very good, and we hope that in the final workshop at the end of November, we will get the same feedback.
Thank you, Armando. And do you have any additional efforts foreseen? Have you foreseen any efforts that are considered necessary to improve the tools?
Yeah, there is a very important need of the sector, and it's the identification of the monofloral products. So for this project, for Watson project, we work with samples from the production years 2022, 23, and 24. Even 25, but there were not enough monofloral samples. This is the most important product because it's the highest price of the honey. In terms of price, is the highest quality of honey product. And yes, we couldn't develop the algorithms for detection, for the identification of monofloral honey products, because we don't have enough samples. So this is an additional effort that we are planning to do after the end of the project.
Thank you very much. Excellent job. Thank you very much, all of you. I would like to thank our speakers for their excellent presentations, and all of you for joining the webinar. We ran out of time, and I would like now to flag that just before we close the webinar, that there is a series of 6 episodes, 1 episode per Watson pilot, on YouTube, airing by Euronews, which is showing the deep dive into the Watson's pilot in a very visual and engaging way. So I do invite you, all of you, to spend a few minutes seeing and browsing these excellent episodes. I would like now to congratulate again the team of the Watson and the team behind the episodes. And I would like to say thank you again for joining and engaging with the Watson pilots. Thank you and goodbye now.
Thank you very much.
Thank you.
Thanks.